Hello, everyone, and this is our second event this month from the AIxDesign community. And this month we were talking about no code, where it's a fast and easy way to create machine learning models for your sites, apps, and more, where there's no expertise or coding required, to say the least. And in light of this month's theme, we invited Nirman Dave, who is here to share his learnings with us. He's the CEO and co-founder of obviously.ai, and they are building a tool for non-technical analysts to run predictions with just a few clicks. So without any further ado, I'm going to let him take over and tell us more about NoCode ML and what the state is. So here we go.
Hey, thanks so much for that intro. Hey guys, thank you all for joining today. Super excited to be here. So I think let's kind of give you a pretext about today's kind of talk. I've kept it pretty lightweight. I've kept it, talking a little bit about machine learning, a little bit about no code, but obviously I'm more than happy to dive into more kind of advanced, deeper topics as we progress. So, feel free to ask me anything and jump right in. So let me go ahead and share my screen, and we should be good to go from there. All right, so can you guys see my screen? Is everything okay?
Yep, all good.
Perfect, awesome. So I've called this talk today as Designing AI for Humans. We're gonna talk a little bit about no code, a little bit about machine learning, a little bit about kind of our design practices and kind of the type of users that we typically work with. So let's kind of dive in. All right. So what I want to go through today is I'll give you a brief introduction about who I am, what we do at obviously.ai. We'll go through what is no code, why is it important. I'm sure everyone here understands what is no code, but we're going to dive into why it's important in the industry today. We're going to go into what is machine learning, what exactly does machine learning mean, how does it work, and then kind of combine both of those things. And we're going to talk about no code machine learning, what it is, why is it important, how do you go about doing something like that. We're going to be touching very briefly on designing for no code tools. So what does it mean to design for a no code tool, right? The design process typically when it comes to building apps or anything like that is very standardized. So how is that design process when you think of no code tools, and why is it built the way it is? We're going to jump into a demo of no code machine learning with obviously.ai. You're going to see how it is the fastest and the simplest no code machine learning tool out there that we really double down on. At the end, I'm going to touch briefly on the future of no-code ML. We can jump into Q&A. But again, don't worry about waiting for Q&A. If you have any questions, feel free to drop it in the chat, or just pause and ask me the question. So happy to dive in there. All right, so let's kind of dive in. I'm going to give you a quick introduction. I know it's kind of stupid to put your photo on the slide when you're kind of presenting, but I thought I would fill up the space anyway. So here it is. That little QR code over there is my LinkedIn QR code. If you want to join, connect with me on LinkedIn, just scan that QR code. So to give you a quick overview, I'm Nirman. I grew up in India, ended up studying computer science and behavioral economics, spent time at Hampshire and MIT in Boston, and kind of started a couple of companies during my time in India, until at one point when I was working as a data scientist at a company in San Francisco, and every non-technical analyst would come up to me. They would ask me questions around machine learning, around data science. They were building regression models, they were building classification models. They would ask me questions around all of that. And that's where the light bulb kind of went up. We said, why is it that the non-tech business users, that the analysts at these companies, they're the ones asking questions about machine learning and data science, but the tools are made for technical people like myself. So we started to kind of look up for tools that our business analysts could use at Streamlabs. And we were kind of, looking at tools like DataRobot, H2O, pretty exciting tools at the time. But again, they were built for someone that had a background in data science, right? They would come back to me, they would ask me questions like, hey, Nirman, what is this loss function? Or can you explain me what recall means? Things like that. So that's where this light bulb went up was, can we build a tool that's insanely easy to use, allows anyone to quickly build their own machine learning systems, and does not require any background in data science. So that's really where the idea of obviously.ai started. And that's what obviously.ai is today. It's a no-code machine learning tool. We're the most simple and the most fast tool out there. And we'll kind of jump into the demo to see just how that's possible. As a company, we're fairly young, started about a year and a half back. We're based out of Berkeley in California, but we work with 1,500 small, medium businesses across the world. We're backed by some of the top investors like Skydeck, Sequoia Scouts, Arca Ventures, and a bunch of those folks. Recently, we were named among the top no-code machine learning tools to use alongside Google AutoML and a couple of other well-known tools that are made mostly for engineers while we continue to build for the analysts. So that's kind of a quick introduction about me and obviously.ai, and kind of let's dive in. So let's talk briefly about what is no-code. I think we all know and we're very familiar with this old wave of tools that keep coming up. You've seen tools in web apps, like Webflow. You've seen tools in mobile apps. You've seen tools in workflow automation like Zapier that are coming up that are doing no code or are promoting no code in their marketing materials. Right. So what is this no code? So I think a couple of years back, as the need for building coded applications, that would mean anything from a phone application to kind of building a script that automatically does some action for you, started to kind of build up among companies where the programming team or the engineering team was not scalable. The engineering team had a lot of priorities that weren't being scaled. And so business users that needed these little coded applications often had to find ways to go through things. That's really where the idea of no code really started. Eventually, the idea of no code took form from something called Scratch, which is a programming language out of MIT, which was a drag and drop programming language. And people decided to kind of build something similar for business users. So we started to see very simple applications like Appian that started to rise up. Eventually, we saw companies like Zapier, IFTTT kind of becoming more no-code driven, no-code focused. So simply put, I think the word no-code means achieving a historically complex task without writing code. It's achieving a historically programmatic task, one which needs programming without writing code. That's as simple as it is. That is what no-code is, and that's kind of where we've come to be today. But the real question is, why is it important, right? Why is this whole no-code thing important, and why should we care? Right? Why is it now that people are really adopting it today? What is pretty clear, but why is the important piece? Now, is programming expensive? Well, common belief is that programming can be very expensive, right? But as you kind of start digging in, you see you use tools like Fiverr, you use tools like Upwork. You can always get a programmer to do a quick application for you, to write a quick script, to write a quick mobile app. You can get one for a couple $100, or you can get one for a couple $1,000, or you can hire a full-time employee for thousands of dollars, right? So that's where it gets expensive. But when it comes to building coded applications, programming is not that expensive compared to budgeting inside a company. Is programming easy? Well, I wouldn't say it is completely easy, but yeah, I mean, people can get things done fast enough. If you are a programmer, you can build a code, right? You can get things done. If you're not a programmer, there are a lot of drag and drop coding tools like Scratch. There are a lot of tools online like Coursera that teach you the basics of Python. In fact, a lot of analysts that we see today in businesses have started to understand and learn some or the other forms of Python. They know how to print something. They know how to use tools like NumPy and add and multiply numbers, things like that. And does it give more control? Obviously, right? Like programming gives a lot of control. It is so widespread that a lot of people can use it, and it's not that expensive, contrary to common belief. So why is it that people still care about no code? Why is it no code that is important? So it's not, first thing is that no code is not important because the alternative is more expensive. No code is not important because the alternative is harder. It's not important because the alternative is easy, right? The only reason, the single most important reason no code is important today is because it has lower time to value. You're going to be spending a lot of time going to an agency, going to an engineer, getting someone to do your job for programming, or learning how to code, or figuring out, even if you know how to code, just kind of building that app and publishing it. That takes a lot of time. It takes you months. Sometimes it takes you like 2 to 3 months. It can sometimes, if you're fast enough, probably take you weeks, but not earlier than that if you're building something meaningful. So the kind of the value that really the inherent core value of no code is that it has lower time to value, right? So anything that you build with no code, you can build it quickly and you can kind of get it out there fast enough. So that's really the idea behind no code and why it really matters today. It is not because programming is tough and no code is easy, but it's rather because no code has lower time to value. And so I think that's going to be the center point for a lot of our conversation today, but that is the key reason why no code adoption has been growing as it does today. So now let's jump briefly into machine learning, right? Talked about what is no code, why is it important? Now let's talk about machine learning and why is machine learning important. And I'm just going to touch the high level idea over here, but again, happy to dive into the more complex details of machine learning if that's where you want to go. The high level idea of what is machine learning, I would like to say is, machine learning is the art of finding patterns in a data set, right? And there are two very important words over here. So let me kind of go through that again. Machine learning is the art of finding patterns in a data set. So there are two important words here. First one is that it's an art, and the second one is that you're finding patterns. So let's kind of dive a little bit more into it, right? So let's talk about finding patterns first. If I give you a list of 5 cars, right? I said, here are a bunch of cars, and there are 5 of them. Tell me something that's common in these cars. Tell me something that you find is common among all the 5 cars. Very instantly, you will tell me, Nirman, all of these cars are of the color red or the color black. All of these cars are either made by the same manufacturer or same company, something like that, right? So it's very easy to say or find patterns in a list of 5 cars. But if I had to bump that up and I said, give me a list of 100 cars, probably it'll take you a couple of hours, but you'll come back to it. And then if we bumped it up one more notch and we said, hey, I have a list of 1,000,000 cars. Tell me what's common. Tell me what do you think is common amongst all of these cars. Now it gets difficult. Now you going out and figuring out what is common and what's the pattern is very, very difficult. And so that's where the machine comes into the picture. The idea is that the machines are inherently fast at doing, routine tasks, automated tasks, that we can somehow get the machine to find these patterns much, much faster than we will as human beings. So that's really what machine learning does at the core, is that it finds these patterns in really large amounts of data. But why is it an art? Right? Why do we call it an art, right? It's not just something you can code and kind of go out there. Well, the key idea is when it's 5 cars, it's very easy to kind of identify patterns. But when it's 1,000,000 cars, we don't know where to look for these patterns. We don't know where to start. We don't know, hey, should I look at the color first? Should I look at the make and the model first? Should I look at the manufacturer first? I don't know where to look for patterns. I don't know where to start when looking for patterns. And that's typically what makes it art, is because we have to use a lot of trial and error. And we start by looking at the colors first, and we say, hey, I think all the colors are red. And then you see a color that's yellow or black or green. And you're like, wait, this doesn't hold true. Let me look at the manufacturers. And then you keep doing that to do what is called a trial and error method, where you keep trying out different attributes or different features of that car to find one that actually makes sense. So that's why it's an art, to identify where to start and how do you go about finding that pattern. So that's really what makes it the art of finding patterns, and that is kind of machine learning in a nutshell. So what do you do about it, right? We found these patterns. We did the art. We got the machine to kind of do some magic, and we found the patterns. But what do you do with it, right? Once you know the patterns, you can eventually use these patterns to predict the future. So tomorrow, if I come back to you and I say, hey, I have a car, that's a two-seater car, has this kind of an engine, has this color, make, and model, is built in this country, tell me what brand it is. Because you know the patterns, because you understand, how these million cars are different from each other, you can tell me, hey, Nirman, likely chance that the car that you're referring to is either made by this manufacturer or the other one. It's just very, very easy to do that once you know the pattern. And that's typically the same in life and same in work. Once you identify patterns about your work, about the people around you, you can kind of get a sense of where you're going. So that's the general idea with machine learning. We get the machine to identify a pattern, and then we use that pattern to predict future outcome. So how is this machine learning thing done? So how do you actually go about doing it? And the quick answer to that is we have a bunch of different machine learning algorithms. These are algorithms that you've heard of, like neural networks, or some not so common ones like naive Bayes, logistic regression, random forest, things like that. These algorithms are the ones that help you find these patterns in different ways. So let's talk very briefly about how we've been doing this art of finding patterns historically, how we're doing it now, and how we plan to go about doing it in the future. So historically, the art of finding patterns, or machine learning, was done through code, right? Enterprises or really large companies would hire PhD data science engineers or researchers to use tools like C#. I don't think TensorFlow was there exactly 7 years back, but equivalent tools to make machine learning models, which would take you about 2 to 6 months, along with a bunch of different people from a bunch of different departments. So you'd ideally have a business, a data science team that would work with a business team, that would work with the suppliers, that would work with the manufacturers, to bring all the data together, to bring all the wisdom together and say, here's a machine learning model that predicts X or that does this. And then the business guys are going to come in and critique and say, you know what, it doesn't actually work, because in reality, here's what we see. And so it became a very, very team-driven process. Team-driven doesn't necessarily always mean collaborative, right? And that's kind of where the problems really start. But let's kind of jump to that in a bit. So that was 7 years back. Today, we see that things have improved, but they haven't improved dramatically. We're seeing tools like H2O, Data Robot, very, very powerful tools. Again, they're used by larger companies or VC-backed companies. This time, companies are hiring masters, graduates, or people that have some understanding of machine learning, and they use these tools to make models in a couple of months or weeks, along with multiple teams. So things haven't changed dramatically. A little bit of change has happened, but I think the key thing that we're seeing is that things still are fairly complicated. People still need a background in data science to really know and understand what's going on. So what's the problem with this thing? The first problem is that it is slow, right? It can take you months to build a machine learning model, even if you are a data science person, even if you have a background in data science, even if you have a data set that's ready to use. It's always tech heavy, right? You need a background in data science, you need a background in the infrastructure architecture to get things going. It's obviously HR heavy, which means you need a bigger team to make things move forward. And obviously it is cost heavy, right? You're spending tons of money to do that. And so this is where no-code machine learning really comes into picture and really thrives. What if we built a tool that was really fast? It's incredibly fast, that can get you machine learning models in a couple of minutes compared to months. What if we built a tool that didn't use programming? So it was built for someone that's not technical, didn't require any programming or data science experience to understand what's going on. And what if it was a one-person job? It was something that a single individual can do without constantly, involving a larger team, and obviously economic. So that's really where we come in as we build out obviously.ai. Is we're building no-code machine learning for the future. The goal is to get small, medium businesses where users are existing business users, they're not PhDs, to use obviously.ai as they can build machine learning models in minutes all by themselves. So that's kind of the quick and dirty overview of what is no-code, what is machine learning, and what is no-code machine learning. So we kind of just put all of that over there. And that kind of closes that first chapter of kind of things that we've seen. So now let's talk about the no-code design. So I'm very excited to kind of walk you through the demo of obviously.ai and go through that. But let me take a moment briefly to talk about no-code design and tell you how we go about thinking when you're building a no-code tool. What is important and how is it different from a lot of different tools out there. So there are three very important steps when you're building a no-code tool. The first step is obviously initialization. You have to enable the user to use the tool. And we're going to go into more deep in a bit. The second step that's very important is activation. You got to engage the user to understand what's going on and how to use it. And the third one is action, value. So let's take a couple of examples. Let's take an example of Webflow. It's an automatic website building tool. An initialization for Webflow would be you jump into the platform, it tells you, pick a template and get started, right? So that's the initialization. The activation is where you're kind of using the Webflow tool to drag and drop tools, kind of bring things together. And the action is the single most important piece, which drives the value of Webflow, is when you publish the website. If you were to build a website inside of Webflow, but you didn't have the ability to publish it, right, the action piece is absolutely not there. That makes the entire product really useless to move forward. So I think these are the three critical steps for no code. Now, this doesn't always apply to all the kind of tools that are out there. You're building, let's say, if you're building a CRM system, you really don't need an action kind of a thing. You just need activation. People are just putting in the data and that's it. If you're building, a messaging app, it's all about action. You don't need initialization. You don't need activation. So it's very much critical to no code that when you're building no code tool, you need initialization, activation, and action. So that's kind of what we need over here. So to dive into that, I think the first kind of user that we typically work with, the three key ideas of users. So the first one is what we call as a common user, right? How do you go about building a no-code tool by understanding who the user is, right? So that's kind of where we're going towards. So the first one is called a common user. A common user is someone that, a common belief is that a common user is someone that is a non-technical user. They don't know the subject matter, possibly stupid, and they're looking to discover value, right? So they need context in everything that you do. So think of a common user as someone that has never used a tool before. And that's really where, think of something like Windows, right? Where they had to have a button that said start. You have to click here to start. So that's what made for a common user. That's a non-technical person who doesn't know anything, and they're here to just discover if there's value in the product. Then comes the pro user, where they just don't happen to know code. They know the subject matter, they're well-researched, they're looking to obtain value. They're not looking to discover value. They already know what they're likely to get. They're just there to get that fast enough. Now, these guys don't need context. And that's like a perfect persona for a no-code user, is because these guys understand what it means to have a website or what it means to have a machine learning app, but they just don't know how to code. So they know the value. They're just there to obtain the value. And that's where you see tools like Webflow, obviously.ai coming into the picture. And then you have the Einstein user. This is the user that pretty much knows everything about the product or the space and is typically always a skeptic, right? So I'd say the sweet spot for a no-code user is someone that's a pro user over here, where they know the value, they're here to obtain it, they're well-researched, they just don't happen to know code. So that's who it's built for. So let me dive right into a very brief demo of obviously.ai. and we can take it from there. So before we dive into the demo, either I can pause here to take any questions, or we could jump right in. So I'll give that a couple of minutes. If you guys have any questions, we can jump right into that. All right, cool. So we'll jump right into the brief demo over here. All right, so here's a data set that I have with me. This data set here is called Telecom Churn. It's a list of customers that have canceled their phone plans from a company called AT&T, and they've gone away to another company called Verizon. And so here you can see every single row is an individual customer, and every column tells you something about that customer. This one tells you the gender of the customer, whether they're senior citizen or not, so on and so forth, until the last column here tells you if the customer has canceled, yes or no. So the goal is that we have this historical data set where we already know customers that have canceled a subscription service, and the goal is to predict which new customers are likely to cancel moving forward. So let's kind of go ahead and do that real quick. I'm going to go to the obviously.ai platform. This is what the platform looks like. We go ahead and start by adding a data set. We can connect to CSV file or any other data sources. For us, we'll use a CSV file right over here. And I'm going to go ahead and upload this file right over here. Now, as I go ahead and upload this file, it asks me a couple of quick questions. It says, is the first row column names? You go ahead and say yes, because that's kind of required. And here it says, are all the file requirements met? You go ahead and say yes. The minimum requirement is at least we need a data set with 1,000 rows to make something meaningful out of it. Now we go ahead and upload the file. And as we do that, it gives you a quick overview of the file before you run any kind of prediction or machine learning model. So here, it tells you all the columns that are there in your file, tells you how much of that column is empty, how to go about picking. On the right-hand side, you can pick a column you like, and it shows you the distribution of that column. The next thing, we go ahead and click Use for Prediction, and at this point, all you have to do is pick the column we want to predict. So in our case, we want to predict the churn column. We want to predict who is likely to cancel the subscription. So we go ahead and pick that column and click Start Predicting. So at this point, it starts by cleaning your data set, up samples, down samples, normalizes data, builds a custom machine learning algorithm, completes that algorithm with multiple different algorithms, picks an algorithm that is the best performing, and gives you a model report right over here back. So we call this the machine learning model that's given to us right over here. And in fact, as you saw, the model is built in less than 1 minute. So that's one of the coolest parts about what we do. We process the model in less than a minute to get going. So in the model, now that we're over here, we can look at the drivers tab that allows us to understand what are the factors that influence people to cancel. Then we can go to the personas tab, where we can now say that I have a new customer. Let's say her name is Tina. And I'm going to put in details for Tina. I'm going to say Tina is a female. She is a senior citizen. She uses a fiber optic connection. And let's say Tina pays $50 a month through a credit card. Tell me the likelihood that Tina is likely to cancel. And it tells you likelihood to cancel is 69%. So what we just did in this process was we took a historical data set, we threw it into obviously.ai to build a machine learning model. The model identified patterns inside this data to say, okay, the people that cancel have these patterns, and the people that don't cancel have these patterns. And then we defined a new customer called Tina. We put in details about Tina, and we said, hey, tell me if Tina is going to cancel. And it comes back to us by saying, yes, 69% probability that she is. So that's the quick kind of overview of machine learning on obviously.ai. There are a couple of other exciting features that you can use. There's something called API that allows you to integrate this machine learning model inside your own web app, inside your own website, or using tools like Zapier, where you can say, hey, every time a customer's probability hits 80%, automatically do this action, right? So these are the kind of things that you can build out with obviously.ai. If you want to get technical, You can click this tech specs tab over here that tells you which machine learning algorithm to use, what are the details of the algorithm, and how well the model is performing. And the most common thing that we see in machine learning is that the algorithms become a black box, meaning you really don't understand how they work. So that's really where the advanced analytics comes in. This one tells you how the system decides whether someone's going to cancel or not. It will walk you through the decision tree that the algorithm kind of uses at the end of the day to identify the outcome. So this is an ID3 decision tree built on top of a logistic regression. Obviously, the data set was very simple enough. The more complicated data you have, the more complicated items and algorithms you'll see. For example, neural networks, naive Bayes, random forest, things like that. So that's the quick overview of obviously AI. And to very briefly sum it up, the general overview with no code and no code machine learning is that the kind of impact we're going to see from this point onwards is we're going to start seeing that there are new job roles that typically never existed. We're going to see job roles for user scientists, data governors, product hackers, job roles that never existed that can now be enabled because of no-code machine learning, because a non-programmer, a non-technical individual in a company can now have the power of machine learning. These are the kind of job roles that we'll typically see. Other interesting thing we're going to be seeing coming up is going to be collaborative machine learning, right? We saw in the past that a lot of teams work together to build a machine learning model, but it wasn't collaborative. It was more like a top-down approach. This time, for the first time, because the models are so easy to share and kind of collaborate on, with tools like obviouslyai, with tools like others that are out there, collaborative ML becomes a very important kind of subject matter as we move forward. So think of it as Figma for machine learning. A lot of people can come in together and give their opinions and thoughts about how to go about with it. And the most important thing we're going to be seeing is that because people have so much visibility in how the machine learning algorithms perform and how they take action, people will be easily able to crack down on machine learning biases, because no more these models are being restricted to the data science team. No more are they being kind of only black boxed, but now even business users and everyone in the company can see how it functions. So we're going to have models with lower biases the more no-code machine learning gets adopted. But that's kind of it. I think that's kind of the overview of my talk. Happy to jump into Q&A. This is my contact. If you're interested, check out nocodemachineLearning.com or obviouslyai. But that's a wrap.
Hi.
I'll just pop in because I think Avantika's connection's probably a bit
Yeah, my connection is a bit dodgy. I'm sorry.
No, I know you've been having it all day, so all good. Thank you so much, Nirman, for explaining everything and your thoughts about, you know, sort of the approach you guys are taking. I think it's really nice to just hear, not just here's the tool, but here's like all the thoughts that go into it and how you arrived here. And obviously it's very much what we're sort of advocating, you know, that yeah, not just data scientists and engineers should sort of have access to this material. I'm really curious. I have a question, a critical one as usual. So I'm really curious, like obviously there is also certain like risks and challenges, I think, affiliated with sort of putting really powerful like ML tools in the hands of people who might not know how to sort of consider certain trade-offs, because yeah, they're just clicking buttons and it spits out the prediction and they're like, ah, nice, great, you know, and they get that insight and kind of take it for yeah, truth, I guess. Whereas of course it is always you know, a data prediction with certain limitations that has been based on specific things. How do you deal with, I guess, some of the like interpretability and sort of, yes, some of these things like evaluating bias and fairness in
Mm-hmm.
things like in no coding tools.
Right,
What do you guys
right.
think about this at obviously.ai?
Yeah, great question. I think one of the single most important thing that we can do as a company, as people that are building a product, is to make sure that we allow our users to have full transparency into everything. We can give them the right kind of information to make a more meaningful decision. I think that's the single most important thing that we can do, and that's something that we are doing as we move forward as well. It is very critical that people don't jump to conclusions, because it's very easy to do that with no-code machine learning or machine learning in general. Now, data scientists are trained and they're wired to make sure that they don't jump to conclusions. But an average person who's not a data scientist using no-code machine learning might just do that. So the key idea here is to design the tool, to really build the tool in a sense that we stop them from jumping to conclusions. So as you see, the first kind of part of obviously when you upload the data, it tells you that the data is fit to be used for prediction. It tells you, it asks you a couple of questions that are very simple. We could validate them automatically, like, is the first row column names? We can validate that automatically, but we still ask the user about it. So these are very simple functions that kind of makes the user a little bit aware about the kind of data they're bringing in the first place. After they've built the model, we try to give them visibility in how the model works. And if there's a bias, it will be very visible in the decision tree. If there's a bias indicator, it'll be visible in the text specs. So we kind of enable the user to make sure that here's all the information that you need to know. Here's all the validation checks that we've done with you before we go about proceeding. And at that point in time, the user can then decide, should I actually use this model or not? As they upload more data, they will also see if the data is fit to be used for prediction, if it's not fit to be used for prediction, things like that. But it's not just enough to give user all the information. So we also have kind of some inbuilt technology that allows you to reduce bias. So an example is if you have a data set, let's say, and the data set has 95% male users, only 5% female users. Now there's an obvious bias there in the outlying machine learning model. So what we do is we use techniques like upsampling and downsampling that are automatically applied to the model, that allow the model to kind of balance out the ratio of the gender on the data set to reduce bias in the final machine learning model. So I think those are some of the techniques that we do. It's not the full solution, but it's definitely a start, and I think we're very critical about it.
Yeah, I think it's good to hear that you are working on this solution. It's it's like nobody's expecting you to figure this out all at once, but I think that makes a lot of sense. And the upsampling and downsampling, is this like from synthetic data, or do you like take it from other data sets, or how do you? It's a bit technical, but how do you do that? How do you like normalize data so it's more balanced?
Perfect. So I think downsampling is pretty straightforward, right? You take a bunch of random data sets, random data points, and drop them. Upsampling, what we do is we basically kind of build synthetic data from the combination of user features within that data set that exists. So we're not really kind of going out and fetching more data, which becomes a pretty complicated process. So that's kind of the upsampling that we do, given we have enough data, right? So if we're talking about typically in at least 100,000 rows to be able to do successful upsampling. For downsampling, you could have a minimum of 1,000 rows. That's fine. But for upsampling, we're talking about at least 100K rows.
Yeah. Cool. Thanks.
Does anyone else have any other questions?
Or comments? I mean, we're not that big of a group, so you can also feel free to just unmute and say something instead of typing in the chat, whichever one seems less intimidating.
I do have a question. So so I understand that obviously AI works with a data set for starting at about 1,000 entries, but how would a company that doesn't have the data get started, or how would a company that doesn't have the habit of collecting data and they don't have a data set prepared, how can they get started?
Yeah, that's a great question. So I think typically, typically any company should think about machine learning or analytics once they have data collected. I think data collection is important. And obviously you can do it in multiple ways, right? Like either you can start data collecting right now. You can do it using tools like Google Analytics that automatically collect website traffic data. You can do it inside your own platform with tools like Hotjar, session information, things like that. So that's fairly straightforward to do. If you don't have any data and you really want to build a machine learning model that does, a particular prediction, you can obviously go to companies or like websites like Kaggle or something to fetch that data. So there's Kaggle, there's Google Scholar to fetch data sets that are publicly available. But I think the critical thing is to think about what kind of data to collect. That's going to be very important as you go about collecting. So what we typically recommend when it comes to machine learning, there are 4 types of data that are very important to collect. The first one is demographic data. So user information like age, gender, location, income, whatever you can collect. The second one is product data. So product usage. How are they interacting with your product? When are they logging in, logging out? What are the functions that they use the most? Things like that. The third one is transactional data. How much they're transacting. Are they kind of doing it via Stripe? If they're not doing it via Stripe, how are they paying you? How much they're paying you? How often they're paying you? That kind of information. And the third one is kind of engagement and support information, right? So as long as you can collect these 4 types of information and put them into columns, I think that would make for a really, really strong data set. 1,000 rows is a minimum that we recommend at obviously.ai because that gives you a meaningful machine learning prediction output. But you can still run machine learning with a couple hundred rows. If you're doing something like time series analysis, where you just have a list of times and a list of users and their values. But ideally, I personally recommend having a minimum of 1,000 rows. Now, this doesn't necessarily mean you need 1,000 users, right? 1,000 rows could be 1,000 transactions, 1,000 shipments, 1,000 orders that you processed. So feel free to be mindful of that. But I think those 4 types of data would be very important as you think about data collection.
Mm-hmm. Okay, thank you.
Mm-hmm.
Anyone else?
Can we try it right now? If I make can I make an account right now and try it out?
Yeah, so you could go to obviously.ai. There's a free plan, so you could just jump in and make an account and get started. You will need to use your company or work email. So that's the only caveat to make sure that you do.
Okay, why is that, by the way?
So we typically do it for our own data collection. So we try to understand where our users are coming from, what kind of job roles they're in, and how they actually use the tool.
Okay, thanks. I'm going to try that. Thank you.
Cool.
I have one more question. So since you mentioned that you're collecting the email addresses for your yourself as well, how do you use obviously.ai, or do you use your obviously.ai too?
Do we use our own tool?
Yeah.
Yes, I think so currently we only have 1,500 users, right? So the way we are using, so we don't have as much data as we want to be using obviously.ai, right? So the way we're using obviously.ai today is to identify kind of our most ideal user persona, right? What are the kind of activities that a user does in obviously.ai that makes them convert the most? So that's the kind of question that we answer. As we move forward, as we'll have more data, we'll be able to say fairly accurately if someone's likely to cancel their obviously.ai subscription or engage in a different way. But yeah, that's how we use it.
I'll have another quick question. What are like some of the common, I guess, sort of use cases that your current users are, like using obviously.ai for? So definitely churn, like that's an obvious one.
Correct.
What else are sort of some of the big use cases?
Mm-hmm. So typically our customers are basically small and medium businesses that don't have a data science team or cannot scale one. And we usually work with, marketing analysts and business analysts in these organizations. Their typical use cases that you would see are very B2C driven. They're very customer driven. So we see marketing use cases, obviously churn. Again, similar use cases like predicting LTV, predicting CAC, predicting cross-sell, upsell. These are very common marketing use cases. But the most exciting use cases that I've seen are some called dynamic pricing, predicting how much a user is likely to pay and charging them that price. In fact, we have two companies that actually use dynamic pricing on their mobile apps to display that number to their customers. So they're displaying varying amounts of numbers to their customers so they can get the most out of it. The other interesting use case is this company in India that gives out microloans to users. It's a credit union kind of a setup. And what they do is they use obviously to predict who to give the loan to and how much loan to give to them. And will they pay back the loan on time? So again, what kind of use case is going to be very open to your job and your role? But as long as you have a data set that's kind of ready to go. So I think it's very much like if you think of like Tableau or Mode Analytics that does descriptive analytics, right? They're going to take the data set, they're going to plot the graph. It doesn't matter what graph you're plotting. Is it about sales? Is it about, customer acquisition? Whatever it is, as long as you have the data set, you can plot the graph. Very much similar is kind of what we're doing. As long as you have data set, you can build a model.
Cool. Nice. Happy to hear there's also like not only marketing applications, but also the loan. That sounds a lot like Tala or whatever.
Correct.
Part of, yeah, nice. I have a last question and then I think we can wrap it up, or unless more people have questions. So you've come like a pretty long way already, right? You have this like amazing no-code ML tool. What's next? Like, what is something that you're sort of excited about to go build next, or maybe also something you're something that's challenging, something you're like, oh shit, we're gonna have to figure that out. Like, what's next for you to learn about and take on?
Yeah, great question. I think one of the key things that we've learned is the history was all about descriptive analytics. You take a data set, you plot it. What we're seeing right now is all about predictive analytics. You take a data set and you predict what's going to happen from it. And moving forward, what it's going to be is about prescriptive analytics, right? You tell me what can I do about the prediction, right? How do I reduce churn? Tell me what to do. Like automatically do an action. And so increasingly what we see more and more users don't really care about building the machine learning model. Right? The model is built, great. Like people don't care about it anymore. What they really care about is what can I do with the model? How quickly can I put it in my workflow? How quickly can I start taking action on it? And I think that's going to be the most interesting part is it's not just about giving them a low code API to copy paste in a workflow or a Zapier integration or something like that, but how can we actually make it actionable, right? So we talked about, when we talked about no-code design, we talked about initialization, talked about activation, we talked about action, right? So people are very well activated in no-code machine learning today across all different tools. You build a model, great. You get an API, great. Right? But beyond that, there is very little to no action that is being involved, where the user can publish the website, just like that, the user can actually take action. And so I think that is going to be very critical. And the reason it's critical is because no one in the industry has really done that very well yet. Companies that are old enough, like DataRobot and H2O, they have technical audiences. So their user journey ends by giving an API. But the companies that are young enough, whose audience is non-technical people, they're still kind of building out this interaction and what it is like to get users to take action. And so that form of user interface is going to be very critical. And that's pretty exciting for me, is because we're kind of at the cutting edge, where like we're building something no one's ever built before. And it's going to be pretty critical to how no-code machine learning is going to be in the future. So that's going to be the most exciting part, I would say.
Nice, thanks for that. I see another question came in, so I think we can do that last. It's from Kunal. He's saying, hey, Nirman, thanks for the talk. Could you speak to the challenges in creating this product and pitching it to small and medium businesses?
Oh boy, I think there are a lot of challenges. I mean, it's tough where to start. I think I could just go on a rant if I talk about challenges. But one of the key challenge was, I think I'll talk about a challenge on the product side and a challenge on the user side and a challenge on the sales side, right? So the challenge on the product side was when we talked about the 3 users, right? Let me see if I can, again, share my screen very briefly. We talked about 3 users. We said there's a common user, which is, according to the common belief, a person who's a non-technical user, doesn't know the subject matter, it's possibly stupid, and is looking to discover value. And then there's a pro user that is looking to obtain value, right? The challenge with pro users is because pro users have some context of what they're looking at, they have some expectation. And so when we set out to build Obviously AI, our goal was to build the fastest machine learning tool on the planet, right? Kind of like superhuman for data science. And when we started to build that out, we were able to successfully build random forests, neural networks, these kind of algorithms in less than a minute, right? And here was the interesting thing. So at the first time, the way our user interface was structured was you pick a column, it builds the algorithm, poof, it gives it back to you, right? And we gave it to some of our pro users. And as people started to kind of use the tool, they said, I'm finding it really hard to trust if this tool is working, if the algorithm is going to be right. I don't know, I can't trust it. I'm like, okay, what do we do? Can we build, can we show you all the details about the algorithms? We did that, they still didn't trust. We built other features that can increase trust, they still didn't care, right? At the end of the day, we realized that the model was being built so fast that they felt that anything that is this fast is really not true. And so we had to kind of manually add more loading time to it, so that the user feels like it's actually taking time to get things done and then has more confidence in it. So that was one of the key challenges that we figured out. It's a very product challenge because initially you don't see it, but then obviously like you understand the mindset and it takes a while to shift that. We've seen very similar sales challenges. We were pitching to an investor. The investor assumed that our tool is predictive analytics, can predict things like natural calamities. So if there's a tsunami that wipes out your customer base, that's the kind of churn you can predict. And we said that, hey, we're not God, we don't do that. And so very quickly we learned that people don't have a clear picture of machine learning and what are the limitations of it. And so a very key part of our sales process became educating, right? Educating people about what is machine learning, why is it important, how it works, and what's possible for you to do. Educating people about why this is not going to threaten your existing data science team. In fact, it's going to help accelerate them. I think those are the kind of things that became our key challenges, and now something that we do on an everyday basis. But yeah, I think I would say those would be the key challenges.
Well, thank you so much for that. So Nirman has actually agreed to share his slides with us after this talk. So we will be putting that up in our post that is coming up next week. So keep an eye out for that. But thank you so much, Nirman, for this lovely talk. And we learned so much. And definitely this was a good top up based on our newsletter that went out yesterday and the workshop that we did 2 weeks ago. So this just cemented everything that we've learned this month about this. But for everyone else, thank you so much for attending. And if you want more information on NoCode ML, feel free to check obviously.ai as well as AIx.design.co, where we'll share other resources regarding this topic and other topics in the world of AI and design. I will drop the link here below. But yeah, thank you everyone for attending, and thank you once again, Nirman. It was really nice to have you.
Right. Likewise. Thank you guys.
Thank you.
Have a good day.
Yeah. Thanks.
Bye.
Thanks, Nirman, for your time and everyone for nerding with us.
Sure. Thank you.
Good night.
Thank you.
Later.
Bye.